Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2197. Replace non-coprime numbers in array. Right. So first, what is this non-coprime numbers? Right. So here if you see the definition, two values x and y are non-coprime if the greatest common divisor of two numbers x and y, if it is greater than 1, right? Greatest common divisor of two numbers x and y if it is greater than 1, where GCD x comma y is the greatest common divisor of x and y, right? So this is the meaning of non-coprime number, right? So for example here, if you see the constants, so all the numbers values here if you see are starting from 1 and until 10 to the power 5, right? This is what given to us, right? So here let's say if I want to calculate the GCD of you can say 10 comma 15, right? So here if I write here 10 like this, right? If I calculate the LCM, right? 2 and here 5 and here 1, that's it, right? Same way if I calculate for 15, 3 and here 5, 3 5 15, right? And here 5 into 1 is 5, right? That's it. So here if you see 5 is the common, right? So 5 is the greatest common divisor of this 10 and 15, right? So 5 into 2 is 10 and 5 into 3 is 15, right? So how we are going to calculate the GCD while we do code? So there is one concept of Euclidean algorithm, right? So what we do, we are going to treat this as a value and we are going to treat this as b value, okay? And here I'm just going to check if my b value, okay, this b value, if it is equal to 0, right? Then in that case simply return the value of a, right? If this is not the case, then what you need to do, then you have to return, okay? And I'm going to call this function GCD again recursively, right? So here GCD, and now here inside this what I'm going to do, here instead of a I'm going to pass b, right? And here in place of b what I'm going to do, I'm going to pass a modulus with b, right? So this is what I'm going to do, right? So now let's solve this GCD of 10 comma 15. So here b is 15, right? 15 is equal to 0, no. Then what we have to do, we have to return a GCD recursively. I'm calling GCD, and now this time in GCD I am passing value 15 here, right? 15 this, and a modulus 15. So a is nothing but 10, and here if I divide this 10 with 15, so here I'm going to get what, I'm going to get the remainder as 10, right? So here I'm nothing calculating nothing but the remainder, right? So this is nothing but 10. So here I'm going to write 10, right? This is done. So this is my new a and my new b, right? Done. Now again check if b this time is 10, so 10 is equal to 0, no. So again I'm going to return this GCD, right? Again I'm going to return GCD, and here okay, and here I'm going to write b now. So my b is 10, right? And here in this place I'm writing a modulus with b. So a modulus with b, do a modulus with b. So 10 divided by 15, right? This is the meaning of a modulus with b, right? So 10 1 10, so here remainder is 5, right? So remainder is 5, so here I'm writing 5. Done. Now here this is my a and this is my b, right? So now here if you see my b is equal to 0, no, b is equal to 5, right? So again I'm going to call this GCD, right? So here again I'm going to call GCD. Now here first I have to write b, so b is nothing but 5, and here I have to write a modulus with b, a modulus with b, right? So here what I'm going to do, my a, right? So here a modulus with b, right? So here a is this and this is a 5, right? So this is how we have to calculate a modulus with b, right? So a modulus with b, right? So 5 into 2 is 10, so remainder is 0 this time. Nice, remainder is 0, right? So here I'm going to pass 0 now, a modulus with b value, right? So done. Now here if you see, this is your new a and this is your new b, right? So now here okay, so here if you see, b value is equal to 0, right? So in that case you have to simply return a, that's it. So we have to return 5 is the output, right? So here non-coprime means two values x and y are non-coprime, right? If GCD of x and y is greater than 1, yes. So GCD of 10 and 15 is 5, which is greater than 1. So that simply means that this both GCD of x and y, 10 and 15 are non-coprime numbers, right? So this is the meaning of this non-coprime, right? So from here you are clear with what are non-coprime numbers and how we calculate the GCD of two numbers, right? So I hope that you guys are clear. So very easy concept, right? Okay, done. So this is nothing but your equilibrium algorithm. Okay, so this is done. Now let's move further. So here let's read the problem statement now. You are given an array of integers nums. Perform the following steps, right? So nums is given to us and we have to perform the following steps. So we have to find any two adjacent numbers in nums that are non-coprime. Okay, so adjacent mean neighboring numbers, right? So like these two, right? Neighbor numbers, right? Like this. Okay, and now if no such numbers are found, right? If there are no coprime numbers, right, then we have to stop the process, that's it. Otherwise what we need to do, we have to delete the two numbers and replace them with their LCM, least common multiple. Okay, so first we have to check if GCD value is greater than 1, right? So if GCD value is greater than 1, right, here it is 5, that simply means that both are non-coprime, right? And if the two adjacent numbers are non-coprime, then what we have to do, we have to delete both. We have to delete both 5 and 10 and we have to replace them with the LCM, right, least common multiple. Okay, so how we calculate the LCM of these two? Okay, how we calculate the LCM of two numbers? So 10 and 15. Okay, in mathematics how we do, so we do it like this: 5 2 and here 3, done. And then here 2 1 and 3, done. And here 3 1 and 1, that's it. Okay, that's it, right? But if I do in correct way, so what we have to do, we have to write it like this first. Start from 2, right? 2 into 5 10 and 15, right? This is the correct way actually. 5 1 and 3, and here like this we used to do, right? We have to go like this, not directly take the max number. Okay, so this is how actually we do, right? While studying in class, I think 6th 7th we do like, right? So here what is the LCM? So same, getting same only, but here if you see what is the total LCM, 2 into 5 into 3 into 1, right? So here 5 into 2 is 10, 10 into 3 is 30, 30 into 1 is 30, right? That's it. So 30 is the LCM, right? So this is how we do in mathematics. But how we are going to do this in while coding? So that is also very simple. So what is your value of A? Let's say A value is 10. Okay. B value is 15. You want to calculate the LCM. Okay, and you already know the GCD. You have calculated this GCD previously. So GCD is nothing but 5, right? This we have already calculated here, right? So what you need to do here, take the A value, right? A value 10 and just divide it with 5, right? And multiply whatever the result you are going to get here, multiply it with B value 15. So we calculate LCM like this simple way. If I say, it is nothing but A into B, and here GCD of A and B in coding. Okay, GCD of A comma B, right? This is the greatest common divisor of both, right? So this is how we calculate. But why I'm writing it like this? First I'm writing A comma GCD of A comma B, and then whatever the result, I am multiplying it with b. I'm writing it like this. Both are same thing, but here if I do a into b directly, and if both a and b are very big number, then maybe we get some overflow error, right? Integer overflow, something like that, right? So that is why first I'm doing it like this, and then I'm multiplying it with b, right? So here if you calculate this, so this is nothing but 30. That's it. Clear? So now I hope that you guys are clear with both GCD and LCM, right? So this is what we need to do, right? Otherwise delete the two numbers and replace them with their LCM, and we have to repeat this process as long as you keep finding two adjacent non-coprime numbers, and non-coprime numbers GCD greater than 1. That's it. Then we have to return the final modified array. It can be shown that replacing adjacent non-coprime numbers in any arbitrary order will lead to the same result, and the test cases are generated such that the values in the final array are less than or equal to 10 to the power 8, and two values x and y are non-coprime if GCD of x and y greater than 1, where GCD of x comma y is the greatest common divisor of x and y. That's it. And these are the constant size. Now let's understand this with an example here. Okay, so here 6 and 4. So calculate the GCD of 6 and 4. So 6 and 4 GCD is nothing but 6 and 4 GCD, right? We have to calculate this GCD. So here 2, 3 and 3, 1. Okay, and same way here for this 4, 2, 2 and 2. So I think 2 is the GCD, right? So GCD is 2 greater than 1, right? So that simply means both are non-coprime, right? So if both are non-coprime, then we have to calculate the LCM. So LCM 2 start with 2, right? 3, and here again start with the 2 and 3, and here 3, 1, 1. 3 into 2 is 6 into 2 or 12, right? So that is the LCM, right? 12, 3 into 2 6, 6 into 2 12, right? That's it. That's the LCM, right? So 12. So now here I'm changing these two value with 12, and then same thing, 3 2 7 6 2, right? That's it. So I am deleting these two, right? I'm picking these two, right? And then if GCD is greater than 1, then I'm inserting a new value, right? This is what I'm doing, right? So here I can do one thing, like I'm popping this element, and if GCD is greater than 1, then find the LCM and then push the LCM. I can do like this. Like if, let's suppose if I have one stack, so initially my number is 6, my stack size is not greater than 1. I need greater than 1 for two values, right? So then let's say I push 4 here. Now my stack size is greater than 1. That simply means we have two values, right? So that is okay. Then pick this and this. Let's say you pick 4 and let's say you pick 6. Okay, you pick top two. You calculate the GCD of these two, right? When you calculate the GCD of these two, you find out that these are non-coprime, right? Then what you are going to do, then you are going to delete these two. Then after deleting, you have to calculate the LCM of these two, and then you have to put the LCM here, 12. That's it. Now next number in nums is 3, so you are going to push 3 here. So again stack size is greater than 1, then 3 and 12 you are going to push. So now again you will find out that their GCD is greater than 1, that is 3, right? So here 12 and 3 are non-coprime with GCD 3, that's greater than 1, and 12 and 3 LCM is nothing but 3 1 4 3 4 12, right? So 12 is the LCM. Now again nums is nothing but again 12 and then 2 7 6 2, right? So here we have already removed this 3 12, and we find out that GCD is 3, which is greater than 1. Then we find out the LCM and we push LCM here 12. Then after 12 your nums is like this 2, so you put 2 here. Then again 2 and 12, GCD is going to be 2 only, right? And greater than 1, so 2 and 12 you are going to find out the LCM, and it is nothing but 12 again, I think, right? That's it. So 12 and then 7 6 2, right? So here you have 12 left, 2 and 12. GCD is greater than 1, so both are non-coprime, and if both are non-coprime, push the LCM, right? Then we have 7. So now here 7 and 12, let me show you the GCD of these two, right? So 7 and 12, there is no common multiple actually here, right? So if you pass them like this, okay, right? So here 7 and then 12. Okay, so here let's say this is your A and let's say this is your B. So B is not equal to 0, then here you are going to put B like this, and then you have to do A modulus with B, right? So here you are going to get 7, right? That's it. Okay, A and B. Then again this is not equal to 0, then here you are going to put 7, and then here you have to do A modulus with, right, modulus with B. So here you are going to get 7 into 1 is 7, so you are going to get 5 here. That's it. Okay, so this is your A and this is your B, right? And then again it is not equal to 0, so here you are going to put 5, and here you are going to do A modulus with B, right? So you are going to get 2 here. That's it. So again your this is not equal to 0, right? So what you have to do, here you are going to put 2, and here you have to put this is A and B, so A and modulus with B. So here like this, 2 into 2 is 4 and 1, right? So 1 you are going to put, then again it is not equal to 0, so this is nothing but B, this is nothing but A. So you have to put here 1, and here you have to put what, 1 uh, A is this 2, so 1 A modulus with B, so like this. So 1 into 2 is 0. Here you are going to get 0, right? 0, right? So now this B becomes 0. So what is the GCD you are going to get here? 1, right? So GCD is 1 you are getting, right? So it 1 you are getting, and 1 is greater than 1, no. So that simply means 12 and 7 are not non-comprime. We don't need to calculate LCM, right? We don't need to poll these, right? So what I'm going to do, I'm going to just push them back to this stack. Okay, both 12 and 7, right? Whatever the values we have popped, and then after that we have 6, so I'm going to put 6, and after that you are going to put 2, right? So 6 and 7 are not non-comprime, clear? And here 2 and 6 and 2 are non-comprime, and with LCM of 6 and 2 is 6, so in the end you are going to get here 6, right? You are going to get 6 here, right? There are no more adjacent non-comprime in nums after that, right? There's nothing left. Okay, and this is over, right? So thus the final modified array is this 12 7 6, and note that there are other ways to obtain the same resultant array, right? So that's it, that's what you need to do, right? So let's write the code. Very simple. I'm not going to say that this problem is actually hard. I can say it's of medium level, right? Nothing hard, nothing is hard here, right? Okay, so let's write the code. Very few lines of code as well. Okay, so here what you need to do is first create stack of integer, and here stack is equal to new stack. All right, and here once this is done, then just iterate over all the numbers in your nums array. All right, one by one we are going to iterate, and side by side what I'm going to do, I'm going to push them to my stack dot push num, right? Done. And here I'm going to keep merging while top two are non-comprime. So here I'm just going to write the comment, right? Keep merging while top two are non-coprime, right? So what I'm going to do here, while stack dot size is greater than 1, right? In that case int a is equal nothing but, let's say, stack dot push, stack dot pop topmost element, right? We have two elements or two or more elements, right? So that's why I'm writing this condition. So then int b, let's say int b is equal to stack dot pop again, and then here I'm just going to calculate the value of g. Okay, g is nothing but gcd of a comma b. I'm going to write one helper method which is going to give me this value, right? And here I'm going to say that if my g value is greater than 1, right, in that case what I'm going to do, in the stack I'm just going to push the LCM of what, a comma b. That's it, this is what I'm going to push. And else if this is not the case, then we have to push back both the elements, right? We already did a pop here, now again push both a and b, right? If gcd is if equal to 1, right? If g value is equal to 1, right? So here I'm just going to do stack.push. So first I'm going to push B, right? And then after that I'm just going to push A back, right? Push A. And if this case comes right, then just simply break from here, right? And that's it. Okay, so this is done. And here what you need to do, return new array. We have to return array list, right? So array list, and in this array list I'm just going to pass the stack. Okay, stack values. So here I'm iterating over nums, right, side by side, and also I'm checking the stack, right? So this while loop, so I'm going to break this while loop, right? Because I don't need to calculate the GCD again and again, right? If both are non-coprime, then just move to the next number, right? This is the meaning of this line. All right, clear? Until then, if my stack size, if it becomes greater than 1, then again and again just if check the top two elements and find out the GCD, right? If greater than 1, then just push the LCM like this, right? So this is what I'm doing here, and that's it. Now just write the code for LCM and GCD. So GCD is very simple, right? This you already know, int A, int B, and here if B is equal to 0, then in that case you have to return A, right? And otherwise what you have to do, return GCD, and here you have to write B, and here you have to write A modulus with B. That's it. Okay, and if you want to write it like this, you can do, right? Okay, so let me just format it. All right, so this is done. That's it, right? Now it looks good. And here okay, so now LCM is also very easy, right? If we know GCD, LCM is also very easy. LCM, here we have two numbers, int A, int B, and here we have to just return A, divide it with the GCD of A comma B, and then multiply it with B. That's it. All right, so this is done. Now let's run the code and see if there is code issue. We'll try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.